recording. I'm going to present the Barcelona JUG group. Can you check that my slide is being shown? Okay.
Yes.
Okay.
It's perfect.
Okay. Well, a bit blurry. Okay. So well, thank you for everyone for coming today to this virtual meetup. We are going to learn about reproducibility as a security measure from Andrew Leonard, that works for Red Hat, but also was taking care of the sorry, the Adoptium OpenJDK builds. But first, I need to introduce a little bit what it is the Barcelona Java user group for those that are not usual suspects in our meetups. Well, we are a group of enthusiasts and techies that we are focused mainly in things related to Java, but not exclusively to that. We have more than 2,200 members, and we are a non-profit association since 2012. So we've been here for 11 years. We open to discuss in these meetings or in other forms of meetings that we've hosted before, new technologies or even methodologies. As I said, not only related to Java. We've covered, I will show you in a sec, several technologies. We are here not only to share, but also to help others to share. So if you want to share something regarding any topic or any idea, any experience about developing, please ping us and we will try to host it and create the event. Here we have different ways of contacting us. I would say that the most updated one is the Meetup one, but you can follow us also in Twitter, LinkedIn, Flickr if you want to check for pictures of the JVC and Conf in the past editions, or even in YouTube, where you will find several meetups and hopefully this one too. Some past events considering several technologies, even methodologies, Quarkus, OpenTelemetry, Spring, or Istio, Kubernetes as well. You can see several technologies that we've hosted before. And as you can see, not everything is Java. So we've covered several new and old technologies. So as I said, if you want to just share your experience or even ask us for a meetup about a specific technology that you want us to arrange it, just ping us and we will try to do it. If you also consider that your company can host any meetup, please also shout about it, and we will try to make the next events hosted in your company. Today we have Andrew Leonard, that is lead build and distribution engineer at Eclipse Adoption, working also for Red Hat, and he's been working for quite a long time in the software engineering. And we are going to talk or to learn today about reproducibility as a security measure. I think this is a tricky word, especially for non-English native ones. Okay, so it's we are going to see how they create reproducible builds, and as I've heard just today, they can do them in every 2 weeks or even every 24 hours. So they have a very optimized and a very reproducible build process to do this. So I don't want to steal more time from this. I'm going to stop share, and Andrew, the stage is yours. Okay.
Brilliant. Can you hear me now?
Yes, perfectly well.
Yeah, thank you for that introduction. Yeah, my name's Andrew Leonard.
and as you saw, I've been working in this industry for quite a while, nearly 3 years with Red Hat now, and over 30 years with IBM. And I've probably been using Java for, well, since the year 2000, probably thereabouts, so a long time. And I'm very keen agile sort of evangelist. I've always sort of worked in agile teams. It's something that I like to follow, and our team is following as well. So today I'm going to just share my screen to start with. Okay, so today I'm going to start off with a quick overview, just a few minutes, of what the Eclipse Adoptium working group is all about. So just a small bit of history. So Adoptium used to be called Adopt Open JDK, but we joined the Eclipse Foundation, must be over 2 years ago now, a rough guess. And we've been working and expanding enormously since that date. Basically, the main aim of the project that I'm working and involved with, Eclipse Adoptium, is in the producing enterprise-ready Java runtimes under the Temurin distribution, get that out, by Adoptium. And as I think was alluded to, we're currently in the middle of doing the April quarterly update, which was released upstream last Tuesday. And we've already published, built, tested, and TCK'd binaries for Temurin on all the primary platforms for all the supported LTS versions and the latest short-term support versions of OpenJDK. So in terms of supported platforms, we support, I think in total platform-wise, it's about, I think, 13 platforms across the various versions. The primary platforms being the standard Windows, Linux, x64 and ARC64 architectures, and also Mac OS, x64 and M1 ARC64 architecture. And then we have a stream of secondary platforms varying from AIX, Solaris, PowerLinux, System 390X, 32-bit Windows, and one or two others. This is a snapshot of the versions that we support. So we support all the LTS versions. We distribute, obviously, the Java JDK 8, 11, 17 long-term support versions. So we're actually just currently doing this April release. So all these binaries are already available for the primary platforms, along with the current short-term support release, JDK 20. So 2001 was published last week. And we also do nightly beta builds for all these platforms as well. So the latest JDK 8U, 11U, and 17U streams, we do nightly beta builds of the current upstream code. Similarly for 20U, and we also do a nightly beta build for the current JDK headstream, so which is currently JDK 21 nightly. So they're beta builds. And those are all available. You can either go straight to the adoptium.net downloads and download your favorite version and platform. There's also an API server that you can use your automation to download the latest and greatest version and platform combination that you're interested in. So secure supply chains is a critical part of what we do at Adoptium, and the different aspects of the people, processes, and technology. So we have various enterprises involved in the community, from the likes of Microsoft, IBM, Red Hat, of course, Google, and various others. We have a dedicated security team. In terms of processes, we're very much moving forward with the industry standards support for SSDF and SALSA. So that's the, I keep forgetting, the secure software development framework, I think, and software level secure software architecture, I think. We're currently SALSA level 2, and we're hoping to hit SALSA level 4 by the end of this year. Process and automation is key as well. All our infrastructure that we use for the build and test environments and automation is all provisioned via Ansible scripting. And we use a full CI/CD pipeline automation for all our builds and tests. And it's all open. So all our build scripts and pipeline scripts are they're in the open in GitHub and Temurin build and CI Jenkins pipelines repositories. So we're very much leading in terms of a open source community. And technology, so this is an area that's expanding over the last year. Reproducible builds, which I'm going to be talking to shortly, is being very key over the last year and moving forwards very quickly. And also another aspect of that is SBOM, system bill of material, software bill of materials, which are available with every Temurin binary release. So a quick overview slide of what Adoptium has by numbers. So the number of simultaneous builds that we do over a release week is about 44. I think it is exactly 44. So that's the 4 active versions of OpenJDK by about 10 platforms each, roughly 10 or 11. And next year, I think that's going to be 5 versions, because there'll be 4 LTS versions when it comes to sometime next year, because 21 is the next LTS. So there'll be 8, JDK 8, 11, 17, 21 LTS, plus whatever the current short-term support release of OpenJDK is. Downloads, so we're knocking on 600 million downloads to date for our binaries, our Temurin binaries. So that's a huge number. So it's certainly doing very well. As I mentioned earlier, we're SALSA level 2, hoping to achieve level 4 by the end of this year. There's a marketplace as well, managed by the foundation, and there's 7 vendors distributions available on there, from Temurin, I can't remember all, Microsoft, Azure, definitely 3 that are currently available on there. We're an open community, obviously, so a working group where people can come and contribute to the community, and we have over 130 contributors in last year alone. There are 11 strategic and enterprise members of the working group, from companies like enterprise members like IBM and Bloomberg recently joined, and then strategic members like Red Hat, Microsoft, Azure, Google, and several others. And ongoing projects. So the left-hand 2 are 2 that I'm closely involved with. The Temurin distribution by Adoptium. So that's the free binaries of built OpenJDK, fully tested, cross-platform, GPL v2 license, and fully Java SE TCK tested, and available for you to download now. They're also go through the Aquavit test cycle. So this is a more extensive set of test suites that we run on all our binaries at release time and nightly. And this provides a more extensive set, many thousands of extended security, durability, scalability, and performance type test suites to ensure the quality of what we're releasing. So this is beyond the sort of standard, if you're familiar with the JT-Reg type OpenJDK tests upstream. These are more extended tests provided by the community. Again, open source in the Aquatests for GitHub repositories. And there are two other projects which I'm not as knowledgeable about. Migration Toolkit for helping people migrate, and also the Mission Control project based on Java Mission Control for monitoring and management. So I think that's my quick overview of Adoptium. I'm now going to move on to reproducibility as a security measure. So why we need reproducible builds. So yeah, this is something that has evolved a lot over the last 2 years. And secure supply chain or supply chain vulnerabilities and attacks has certainly put this to the forefront of people's thoughts and minds, especially in this day and age. And one thing that a reproducible build demonstrates, it demonstrates the confidence and quality in your production process for your JDK. So the Temurin binaries that we produce, we can build them repeatably from the same input source to create an identical JDK binary, as opposed to doing a build of the same thing and getting a different output, which just by the sound of it doesn't sound great, does it? You think, why are you getting something different each time you build it? That's not good. So it as a consumer of your binaries, it gives, first of all, it gives confidence in what you're building. And one of the reasons it gives you confidence is because to actually achieve reproducible identical builds, you need to be a lot more stringent on the process in which you build them, and the detail that you track and log in terms of building it. There's quite a large envelope of what's needed, especially for OpenJDK, being the complex nature of it. Because in building OpenJDK, as you may know, there's lots of native code from C code, C++, macro assembler code, to obviously Java code. A huge plethora of different types of source, which is built together into various jars, JMods, native libraries, and installers, etc. So there's a whole pack of different tooling dependencies that in building that reproducibly, you need to know and log each binary that you build. Quite simply, deterministic behavior is far more favorable than random. I think that's quite an obvious statement. So it also goes hand in hand with the industry standards that have been talked about now with SSDF and SALSA. And this last point, which is the main point really, or one of the main points, is enabling secure supply chain validation. So if you can always produce exactly the same identical JDK binary from the same input, it therefore enables a third party to do a validation build in their own happy, secure environment based on the details that you provided. You're building this tag for this version of JDK 17, say, or whatever. And they can build it in their environment they know is secure, this third party. And they should, if all goes well, produce like byte for byte identical to what is published by Temurin at the Eclipse Adoptium community. And what that means that it gives a large confidence in the reliability and trustworthiness of that binary provided by that Temurin distribution, Eclipse Adoptium. The link at the bottom is actually a blog that I wrote middle of last year, expanding on this a bit more detail for reference about what we've been doing. So another aspect that we have implemented or are implementing it with our Temurin distributions is the use of software bill of materials. So you may have noticed if you're downloading Temurin that there is an SBOM, as we call it, packaged with our binaries. And that is a Cyclone DX JSON format standard. And that provides, at the moment, it provides a limited or a minimal set of bits of information, and we're looking to build on that over the next few months to be a far more inclusive set. Currently, the information in there is enough to rebuild identically from, and I'm going to demonstrate or show you a demonstration of that shortly. But which is the main aim at the moment, so that given an SBOM for a given JDK binary release, you can rebuild exactly the same in your own environment from the information within that SBOM. And there's also two aspects to SBOMs that are critical. One is the reproducibility aspect of an SBOM, in that it provides the information to rebuild identically that artifact. But also, and this is something we're going to be building on for our Temurin distribution, is logging in the architected attributes of the SBOM, the tooling and dependency information to help CVE tracking purposes. So, because when you're looking at a JDK or a given binary, having confidence in knowing, okay, was it built with this version of, say, GCC or even using something like a certain version of zip that is known to have maybe some vulnerability or not. So having all that detail there, so you can see, okay, it was built with this a version that contains fixes for these vulnerabilities, for example. So those are two key aspects: the reproducibility and the awareness of vulnerability tracking. Okay, so where are we at the community in terms of our reproducible journey? I call it a journey because it's something, you know, we've been working on bit by bit using our agile processes over the last year, and we're along with the upstream community, OpenJDK. So Temurin JDK 1704, that is the sort of minimum version that supports nearly identical reproducible builds. One aspect that's not are the CDS archives, which in their nature, because they're memory dumps, are quite hard to make deterministic. But that has been solved upstream in JDK 20. So JDK 20 is identical when built on most platforms. And we're working on in progress at the moment in updating our Jenkins CI tooling to help track, record, and publish our reproducible statistics. So our plan is to, for our nightly builds, for example, and including our release builds, publish our daily statistics of how reproducible all our builds are. Ideally 100%, but it's again, publishing these statistics helps give confidence to consumers that they can see the statistics of this distribution that we're has been 100%, say, reproducible since whenever. It gives confidence to the consumer that these are secure binaries. So we hope to get that implemented in the next quarter. And also, as I mentioned, in SBOMs is an area that we're working actively on. We're currently working on expanding the metadata in the SBOM to include all the details for reproducibility. We're also implementing a framework for signing of the SBOM using the JSON signature format specification to add trust to the content of the SBOM, along with the similar signing of all our binaries. And another piece of work, which ties into what I mentioned on the previous slide, adding the full dependency tracking into the metadata of the SBOM for aid of vulnerability tracking purposes. So as you can see, there's a steady stream of work that we're you can find issues covering these in our open GitHub repositories. So how did we get here? So sometime early last year, when I started working on this, I started working upstream with the OpenJDK community. And there had been some work already done by mainly the Oracle build team to achieve reproducible builds, but there was quite a lot more work required. Myself and the team helped move that forward significantly. So, for example, here are the list of some of the key upstream OpenJDK contributions which I contributed. So one of the key ones, so jars and JMods, which you're very likely aware of, we added the addition of the -date timestamp option so that you could deterministically timestamp the contents of the jar and JMod. And also several fixes to the composition of the jar and JMod to ensure deterministic content sequencing, basically sorting of some form, so that when it's constructed, the actual jar or JMod binary is deterministically built, so you can binary compare it, basically. So essentially jars and JMods are a form of zip. They're basically zip entry type content, which has obviously a certain format that is that its total binary form is determined by its sequencing and things like timestamps. Timestamps, as you probably might have thought, are the bane of reproducible builds. A lot of the work upstream for reproducible timestamping was mainly done by the Oracle team with the implementing of the with source date configuration option, which leverages mostly the standard of using source date epoch, so that various toolings will use a given timestamp when required upon that setting. That was the main piece upstream that helped resolve timestamping. The other contribution that I worked on was enabling OpenJDK make build process to produce deterministic zip files. So one of the problems with, especially on various different platforms with zip content, is it's not always deterministic using basic zip tooling. So using the standard zip command. So I wrote, which is in it's actually a small Java application that's part of the OpenJDK tooling set called Make Zip Reproducible, and it rewrites the zip entries of the zip file to ensure a deterministic identical content. So that was one piece. And then there was various other fixes for mainly deterministic ordering issues in various places during the build process. So ensuring things are either added or listed or in deterministic ways, be it keys put into key stores, for example, or just files that are added to jars, etc. Another non-deterministic behavior that is quite a common problem seen with native code compilation, C code or macro assemblers, is due to the effect of building in different workspace locations. So there was various upstream OpenJDK changes by myself and mainly the Oracle build team to enable using various compiler extensions to produce deterministic mapping of these folders. So rather than typically absolute file locations, sometimes using relative, and also in relation to debug symbol files, using the various compiler mapping extensions there as well. Which brings me to the last point, which was another quite a tricky problem to resolve, is making the debug symbol files deterministic, which relates back to the binaries, the things like the native libraries, because they're actually tied so that native debug symbol files are directly linked to the natives for which the native library for which they're for. The native library has a CRC for the content of the library, and so it's sort of key that the symbol file is obviously reproduced itself, and if it's reproducible, then the CRC code in the library will be the same as well, therefore both being reproducible. And various prefix mapping options are needed to achieve that as well. And in terms of the time period in which most of these fixes were done into upstream JDK, they were mostly done from JDK 18 onwards, and I backported most of them to JDK from JDK 1704. Okay, so reproducing a Temurin JDK binary. So our Temurin build is our GitHub repository that contains our build scripts that users can, well, we use, and users can use, it's open source obviously, to build Temurin JDK binaries. And you can use that to build reproducibly JDK 17 and beyond, release type builds, and you can actually reproduce nightly builds or a specific build reproducibly using options within that build script. There's a because nightly builds are based on building the sort of latest head stream, you're effectively building a given commit effectively. So there's an option in the Temurin build to say a nightly builds typically have a timestamp in them. So we added a Temurin build bespoke option to rebuild a nightly with a given timestamp reproducibly. So in that link there, there's also an instructions on how you can build a Linux OS Temurin within our provided Docker build container. Gives you a simple environment to very easily rebuild Temurin. But what I'm going to show you actually is a new reproducible script that we've just published, and it's sort of still a little bit work in progress, but it enables reproducibly building a Linux Temurin JDK from an existing release SBOM. So basically, using this script, passing it 2 bits of information: one, the URL of the SBOM for the Temurin release that you want to rebuild, and also the Temurin URL of the Temurin distribution release for it. And this script will build on your local Linux machine, rebuild using the exact same tooling set provided from the information within the SBOM, rebuild the exact same code that the given Temurin distribution was built with, and at the end we'll do a simple diff compare with the Temurin distribution which it will download and compare with, and tell you how binary identical or not they are. So I think, oh yeah, one too far. There we are. Demo. Right. Let me just go out of the slideshow. This could go horribly wrong. There we go. So what I've done, because actually rebuilding it, what I'm going to do is what's described on what I've already done, because building it takes about half an hour or so, depending how quick your machine is. I've ran this earlier, and I'm just going to show you what it achieved. Basically, what I did is cloned our Temurin build scripts repository, and then in a directory under there called tooling, there is this script, which, as I said, takes the SBOM URL and the tarball URL. And what I ran on my VM, which I'm going to show you in a minute, is this exact command here. So here you can see the URL to the SBOM for the 20.01+9 build that we released last week, and the associated tarball for that Temurin release last week. Okay. So if I go over here, and as you can see here, I ran that exact command I just showed you. And what it does actually, the script will first examine the SBOM to work out, okay, what OpenJDK does it need? What OpenJDK boot JDK does it need to build this JDK? Because to build a JDK, you need a boot JDK. What version of the exact version of the compiler do I need to download to rebuild it as well. Because in order to build reproducibly, identically, you need to build using the same compiler version exactly. And a few other bits of tooling as well that are required from the SBOM information. And as you can see here, it downloaded and installed various bits of packaging, passed the SBOM, downloaded the JDK 1902+7 boot JDK that it was built with. And then it unzipped those. It downloaded the GCC 11.2 compiler that it needed. It then went on to commence, configure, and do the actual OpenJDK build itself. So this bit here, this output here is from the Temurin build script output. So this is output from our Temurin build script. So the first output's the build configuration. So you can sort of see from here what it's doing. You can see using this boot JDK. You can see what I'm building this. I'm actually building this on a RHEL 7.9 machine. We're building JDK 20U. We're building, where are we? It's a release build. It's not a nightly beta build. It then goes on to download the required also dependency for the that's the sound device that's needed for building OpenJDK. It's building JDK 2001, and it's now, so one of the things that the Temurin distribution uses Mozilla certs for the security CA certs, and that runs a script which generates the required CA certs bundle to be passed to the OpenJDK build. So that's what's doing there, and it's processing those certs. There's about 140 or so of those, 139. And it then initiates the bash configure for the OpenJDK build itself. So here you can see it's doing the, or here, running configure with arguments. It's doing, this is the matching the exact bash configure that was used according to the SBOM for the reproducing that exact JDK 2001+9 build that was built by Temurin last week. And then this is all the output from the OpenJDK configure. There we go. And then it starts, does the make, doing the exact same make dependency build as specified by Temurin. It compiles, builds the whole of the JDK. Nearly there. Sorry. And there we go. There we go. The Temurin build scripts output the Java version after building it. So as you can see, Temurin 2001+9. It then runs the SBOM tooling. So this is all done by our build scripts that you can download and use. So we have a Cyclone DX plugin that builds the SBOM for us. So here it's building its own SBOM. And here's the contents of the SBOM. And then it's then archiving, creating the various tarballs. And then it's complete. And at the end, that's marking the end of the actual build. And then this build and compare script then does a compare, which is that bit there. And as you can see, so there's actually only one file difference, which is the release text file. And that's only different because I realized I've got a down version of Git on this rel VM I've provisioned, which therefore doesn't set these 3 properties in the release file. So I need to fix that, basically. But as you can see, the whole of the JDK binary is so it's compared the whole of JDK 2001 JDK folder, which is an unzip of the downloaded Temurin released tarball, to the one it's just built in, which is expanded into this directory here. So it's completely binary identical, which is great. Good to see. So you'll feel free to try that out yourself, following those exact instructions if you like. Let's go back in the slideshow. Okay, so to finish off, reproducibility for your enterprise. So, why would you want to do this? Well, as we mentioned about secure supply chain attacks, this gives you great advantages, especially in the third-party trusted validation build type scenario. It also demonstrates to your consumers of whatever your product is, the quality and reliability of your processes in building your product. If you build the same thing from the same input using the same tooling identically, you're demonstrating a repeatable, reliable quality process. And also with the expansion of the SSDF and SALSA industry standards, this all feeds into a key part in achieving those standards, those security measures. So how? So I've mentioned several aspects in this talk. One, a lot of what I've been utilizing is shared through a community called the reproducible-builds.org, which is a community of individuals and enterprise representatives who have been committed for several years achieving reproducible builds. I went to their meetup in Venice last year, and there was about 20, 30 individuals there, and they're constantly refining and publishing latest bits of information on how to make reproducible builds. So if you go to that website, you'll find lots of fantastic information that might help you solve potentially why you're not reproducibly building your product. So another aspect is in demonstrating and advertising how reproducible your product is, because it's obviously great that you're reproducible, but you want to demonstrate to your consumers. So showing your reproducible stats is obviously key to demonstrating your quality in your process, as well as sort of demonstrating your level of compliance with the various industry standards. As I mentioned, Adoptium is hoping to achieve level 4 SALSA by the end of this year. And the last point, as I mentioned, the trusted validation scenario. So someone, a third party, can validate identically your binary in their secure environment. And I think that's it. Last sort of slide there is some references that I've mentioned. Okay, any questions? I've talked a lot there.
While people can add some questions to the chat panel, I would love to ask.
Sure, yeah.
I would like to ask a first question. That it is okay. We've seen how to make reproducible builds. How well all the things that are involved in reproducible builds that we are not very aware sometimes, that we just simply build some things and if the hash is not always the same, and you cannot always have exactly the same artifact generated. But connecting with one of the comments in the comments pane is why a team would be interested or concerned about creating this level of reproducible builds. So just make it, so I will put more context on it. I do my builds regularly without putting any effort on considering if the build is exactly the same with the same code every time. Why should I be concerned about that, and what are the issues that I will avoid, or the benefits that I will take from that?
Yeah, so I mean, first of all, if you're building the same thing and producing different output each time, then it doesn't give you a level of guarantee. You know, am I introducing some random behavior in each of those builds that, well, it could be dodgy, it could be vulnerability, I don't know. If you think from the consumer's perspective of what the consumer of your product, whatever you're building, in that with the high levels of secure supply chain attacks, confidence, a consumer will pick a supplier which they're more confident is secure over someone that's not. Okay, so if you can demonstrate and you can show history, like which is why I mentioned publishing stats of how reproducible you've been, and your consistency, it shows a level of quality in what you're producing. But also, if you're an open project, and you can say to a third party, you can reproducibly build our open project identically in a secure environment, and you could potentially, provision a given third party to do that for you, to add a sort of statement of trust to your product. If they can reproduce it in a secure environment where they're absolutely sure of the trust of every component of the compiler or dependency that's been built in that environment, and they produce a byte for byte identical as your one that's available on your website, then that gives a high degree of trust that the one that you're publishing is secure. That makes sense?
Definitely. So I mean, from the security point of view, makes totally sense. Also, just giving this confidence to the consumers of what you are producing.
Exactly.
Yeah, definitely.
Yeah, and don't miss out the bit about SBOM. I like to always include the message about SBOMs, which is sort of tied in. It's also tied into the industry standards I mentioned with SSDF and SLSA. It's sort of part of the secure supply chain story, because from that you can do reproducible builds, but also you've got vulnerability capabilities from those as well. And things like Cyclone DX, which is there are several providers of SBOM formats. Cyclone DX is one of them. SBX is the other common one. But we're currently using Cyclone DX, and that's sort of a very fast-growing standard, which is being built upon to provide more secure supply chain part information. As some of you probably aware, the US federal government requirement on bill of materials now, means that at some point it'll come to a point where you can't sell into certain markets unless you've got those standards. So that's critical, obviously.
Yeah. Here we have, I think, 2 questions from Michael. We now have SBOMs for standardizing ingredients. Do we need another standard for the receipt, so the environment, tools, and build instructions to all be able to bake the identical cake?
So you can do, and as I sort of mentioned with Cyclone DX, they are actually expanding into doing all that, including the recipe. So I think you don't need it, but you could say someone that does provide that, you might be more favorable to a consumer than someone that doesn't. It's, you know, it comes to, if you want to tick all the boxes and sell to more consumers or whatever your consumer is, if you tick all the boxes for all those, you're more likely to be in a better position.
Yeah. And another question is, have you ever been able to trace actual bugs in the JDK back to non-reproducibility changes between different versions?
I think no is probably I can't think of. I mean, it's, you know, as I say, we've only been working on this for a year, and it's sort of in our project. I think the last 6 months has been quite a large advancement for us. The SBOMs is definitely a relatively new part that we've added, and is growing. We're doing a lot more work in the next couple of months for. Or we were. Do you see any relation between reproducibility and the final product?
I would assume that Michael is trying to say that if for adding this non-reproducibility or this reproducibility plumbing that you are adding there, if that impacts on the quality of the product. That's how
I see what you mean. I see what you mean. Yes, I think I see in the question. I think so. You know, I'm just thinking. Actually, I think I might. So we have actually had one incident. It wasn't me actually. It was someone else on my team. I'm trying to remember what the scenario was. I think it was in JDK 1705. I think. But one, perhaps not quite what you've stated there, but one example of how we've used it in our project, because we're doing managing an awful lot of platform builds and multiple versions in our automation and pipelines, and we're continuously improving those pipelines. One validation test that we now can do on at least the JDK 17 and above is when we introduce some new work to our automation for building and our pipeline scripts, is to do a reproducible build. So rebuild the previous release using our new tooling of that previous release. And obviously it should be binary identical. If it isn't, then there's something amiss. And that has actually found one problem that we had in our scripting. So sort of what you were asking about there, but that is a really good example, and we do utilize that. I should have mentioned that actually. I'll add that to my slides for next time. Yeah, it's a good question.
Okay. Well, if no one else is adding any other question, this is the last moment to ask questions. If not, well, we'll wrap up. It's been a very interesting presentation, Andrew. A lot of things to consider, and I would say that when I give a talk, I always want to at least sparkle or light a sparkle of curiosity on people, and definitely you sparkled. You light a sparkle of curiosity in me, because I didn't think about this reproducibility concept as something important in the past, but now as you have presented it, definitely I need to pay more attention. Definitely I will take a look to that. And once you share the link for the presentation, I will definitely go back and check the references that you added, because
Certainly, yeah.
so it looks interesting. I never thought about this before. That's that's a shame, but now it's interesting.
Yeah, no worries. I mean, yeah, I'm there on Slack. If you please come join us at the Adoptium Slack community.
Mhm.
And feel free to ping me any queries, questions, or whatever you like. We're very active on there, as you've probably noticed if you're there already. So thank
Okay.
you for listening.
Okay, no, it's
And
been a pleasure.
Yeah, no worries.
Okay, I will stop recording.